This is the last section on meta-analysis of prevalent or proportion dataset. So the aim of this section is to just take you through how to do a meta-analysis of prevalent estimate or proportion dataset. So you may have two or more studies that reported prevalence estimate that you want to pull together and see what, on average, was the prevalence of the particular condition across studies. And we are going to use the following 5 steps to do this meta-analysis. The first step is to load the dataset. So we are taking this dataset from the recent study on the prevalence of underlying disorder in hospitalized COVID-19 patients that are admitted. So we want to look at the premorbid condition. What are the conditions that they are presenting with in addition to the COVID symptoms? So we are going to load the dataset directly using Stata, then describe it. So we have just 5 variables: the study name, the premorbid condition, then the number that explains that condition, then the sample size, then the percentage male included in the study. So we would like to see what are this premorbid condition. So say we have 7 on chronic kidney disease, hypertension, diabetic mellitus, malignancy, chronic obstructive pulmonary disease, and cardiovascular diseases. These are the 6 premorbid conditions. So the aim of this meta-analysis is to find out what's the most commonest premorbid condition reported and the least commonest conditions. So for declaring dataset, as of now, this section is not really relevant for the main meta-analysis because we are going to use another command which is called metaprop. So we use metaprop, which is a user written command. Then you need to install it on your system before you can use it. Then you just say metaprop r number of events overall sample size, then it will give us, and this is the prevalence estimate. It's reported as in proportion, so we can change it to percentage to make it more readable. So then we've added label to it so that we know the name of the study. Then you can raise it to power of 2, that's times 100. So we can see that the pool estimate is about 6.8% of patients reported with one of these 6 premorbid condition on average. Then so what is the commonest premorbid and which one is the least common? So we do subgroup analysis by this, and we found that if we do it by this subgroup, so the CKD, the pool estimate is 3.6, for hypertension is 16.4, diabetes is 9, malignancy is just 1.5, COPD is less than 1%, CVD is 12%. So the most commonest ones are hypertension and cardiovascular disease, and the least commonest are COPD and malignancy. Then we can check whether there's correlation between percentage male included in the study and the number of the sample size, whether smaller study are more likely to overestimate this premorbid condition. So we use meta-regression for this analysis. So from here we can now declare data set as a generic one because the metaprop has calculated the prevalent estimate and the standard error. Then we can take it from here and declare it. Then look at the relation between the male and the percentage of male included and the prevalent estimate. There's no association, there's just no correlation between that. Then the sample size, there's significant correlation between the sample size. As the sample size is increasing, the prevalent estimate is decreasing, which shows that the smaller study tended to overestimate the prevalent estimate. Then we can check whether there's evidence of publication bias or not. So if we do the funnel plot, you see there's no evidence of publication bias, it's symmetrical. The p-value is less than 0.1, so it's still not significant. Then in terms of imputing whether there are missing study, no, there's no imputed study, so it shows that there's no evidence of publication bias. So let's go to Stata to do this analysis, you first load the data set using the use command and describe your data set. Then we can do the meta-analysis, label it, and raise it to power to very high for hypertension and cardiovascular disease, and very low for COPD and malignancy. So these are the commonest ones, and it is the least common ones. No association between percentage male and the prevalence estimate. For the sample size, it's a negative correlation. As the sample size is increasing, the prevalence estimate is decreasing. So smaller study tended to overestimate this. Then let's check for publication bias. You use meta funnel. No evidence of publication bias here. From the funnel plot, the format test, no evidence to read. Then meta train, no study was inputted, so we can conclude there's no evidence of publication bias here. So in summary, we've conducted meta-analysis of proportion or prevalence data estimate using recent COVID-19 dataset comorbidity, and we check for the commonest comorbidity condition, the least common one reported in study. So this brings us to the end of meta-analysis. Thank you.